Hi everybody, I'm Professor Rad, and today we're going to talk about measures of center, or more commonly known as averages. Specifically, we're going to talk about one type of measure of center called the mean. So first let's talk about what that means. An average or a measure of center is an attempt to find a value that appropriately summarizes the data. So in this course, we're going to discuss 4 different types of averages, which we're going to call measures of center. Now, when we think of an average, typically we think of what's called the mean. That's when you add everything together and then divide by however many things there are. So the mean is found by adding things up and then dividing by however many there are. Now, part of an issue with this formula is how can we indicate this idea of adding things up? So mathematicians came up with this like pointy looking E thing, and that's a way of representing adding things together. So this pointy looking E thing means add together, and X is usually used to represent a data value. So when you see this notation in a formula, it means you're going to add together all the data values. So that's that shorthand they're using. And this pointy looking E thing does have a name. It's called sigma. Now, we saw sigma in a few videos ago, and that sigma that we saw was a lowercase sigma, and this is a capital sigma. So the Greek alphabet has upper and lowercase, just like our alphabet. So this is the uppercase version of that. So don't let this notation intimidate you. It just means add everything up. In that video I was referencing, we also saw X bar and mu, and these were the symbols that we used to represent the mean. So X bar represents a sample mean, and mu represents a population mean. So sample mean, population mean. I have the formulas for both of these here because in the future we're going to be looking at sample and population formulas that are different. These formulas are the same. So whether you're looking for the mean of a sample or the mean of a population, the process is the same. You add everything up and then you divide by however many things there are. But for some things, the formula for the statistic, the sample value, and the formula for the parameter, the population value, are different. So we want to get used to this sort of notation for measures that we're going to use a lot. And the mean is one that we're going to use quite frequently. All right, so why don't we go ahead and look at an example of finding a mean. So this example says, Chuck is curious which group of congressmen are older, the Senate or the House of Representatives. He finds an SRS, or simple random sample, of 12 senators and an SRS of 15 representatives from the 118th Congress, and he lists their ages at the time in these 2 tables. Let's find the mean age for the sample of senators and the mean age for the sample of representatives. And then it also tells us to give our answers to the nearest year. All right, so what I'm going to do here, since we have 2 data sets, is I'm going to show 2 different ways that you can indicate your work when you go to find the mean. So you do want to show your work when you're using the mean formula. And here's one way that we can do that. So let's start out with the senators data set. So this is a sample mean. So I'm going to put X bar. Actually, I should put sen. I'm going to use that to represent senator here. So X bar is found by adding everything up. So I'm going to do 64 plus 66. And I'm just going to write all of these numbers being added together. Okay, so it says there were 12 senators, so I'm just going to count to make sure I have 12 numbers here. okay? And then I'm going to divide all of that by 12, since there were 12 numbers. And then I'm going to add those up. So I'm going to bring my calculator over here. And, well, I guess I'll just reference the table here. So I'm going to add up all these numbers. Let's see, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay. And I get 785. And now I'm going to divide that by 12. Okay, so I get 65.416 repeating. So let's just go ahead and round that to the nearest year. So since the digit after the decimal point is less than 5, that means this is going to be 65. So X bar is 65 years old. And that's for our senators data. So one way that you can show your work is by writing down all the numbers you're adding together. Tell me what you divided by, and then you can give your answer. I'm gonna do a little different space here, and this is going to be for the House of Representatives. Now, maybe you're thinking, do I really have to write all of that out? The answer is no. So I'm going to show you another way that you can show your work so that I know what you did to get your answer. All right, so now I'm going to find the mean of these numbers here. And what I'm going to do is I'm going to indicate that by writing the formula to show that I added together all the data and then I divided by however many there are. So this formula is telling me, somebody who's looking at your work, what you did to get your answer. So I'm just going to go ahead and type all of these numbers into the calculator, just like I did before with the other data set. 53 and 46. Okay. And I'm just going to go through and check since this is a large data set. So I'm using this little key thing here, or these arrows, to scroll back through the numbers to make sure that I typed them all in correctly. Oh, why do I have a minus there? That's weird. Glad I checked. All right, and then I'm going to scroll back to make sure I didn't do another minus somewhere. That was strange. But you can also do this too if you're worried and you want to check your data, your entry. All right, so now I get 852. And so to show my work, I'm going to write that total here. And then there were 1, 2, 3, 4, 5 times 3 is 15 representatives. Then I'm going to divide that by the 15. And I get 56.8. So this is going to be 56.8. That would round to 57 years old. Okay. So there we go. 2 different ways of showing our work to receive credit. One way you can write out all the numbers, and the other way you can just add them all on your calculator and tell me what total you get. What's important is not only that, but also that I know what number you divided by. So you don't want to just write n here, you want to tell me what n was. Now, I do want to show you a common mistake that I sometimes see, especially with this first way of showing your work. So I'm going to go back in and type in all the senator data. So one common mistake is to type all the numbers in being added and then just go ahead and dividing by that 12. And this time I got a different answer. I got 715 point repeating 3, which is nowhere near 65, right? So this happens because your calculator follows the order of operations. And when I typed all of this in, at the very end, let me come back up here. At the very end, I have that division. And your calculator says, according to the order of operations, dividing is more powerful than adding. So what it's doing here is it's dividing that 76 by 12 first, and then adding everything else. So that's why we get this sort of 715, this answer that makes no sense. Remember, a measure of center, an average, is supposed to indicate like what's typical, and this makes no sense. A senator on average is 715 years old. I mean, no. So we want our answer to look more like what the data looks like. So if you get an answer that doesn't make sense like this, you always want to check it. In this case, I can type it in one fell swoop, but in order to do that, I need to put parentheses around what it is that I'm adding. So I'm just going to scroll back over here and add parentheses. And now if I hit enter, I get that number we got before. So if you want to, you could put parentheses right in here in your work so that you're less likely to make that kind of mistake in the future. All right, so this technique that we've used is called finding the mean for raw data. We had just raw numbers here, just listed out. Then in the next example, we're going to look at what happens if our number has, or our data has already been sort of organized for us in a frequency distribution. Okay, so here's the notation that you might see for finding a mean using a frequency distribution. But before I do that, before I talk about this notation, let's actually just find it first, because I think it'll make more sense if we kind of go in the other direction with this example. So in this example, it says a simple random sample of 16 children are asked, how much money did you get from the tooth fairy for each of your teeth? And the results are stored in this frequency distribution. So it looks like, for example, 2 kids got $10 from the tooth fairy for each tooth. Wow, somebody was really lucky, got $20 for each tooth. Whew. And 5 kids got $1 for each tooth. So we want to find the mean of this data, and we're going to round to the nearest cent. Now, there are a couple of ways to approach this. One way would be to sort of brute force it. So I'm going to show you what that looks like, although ultimately this is not a technique that I would generally recommend. So we said 5 kids had $1, so I'm going to add 5 ones. So 1, 2, 3, 4, 5. 8 kids had $5, so I'm going to add together 8 copies of 5. So 1, 2, 3, 4, 5, 6, 7, 8. Then we have 2 copies of 10, 1, 2, and then a 20. So when I add all of those up, I got 85. So I'm just going to jot that down over here as a reminder so we can check this technique that we're going to use. So in this case, it's not too bad because our frequencies are fairly small, but let's say you had like 87 and 203. I don't want to be sitting here typing in the same number 87 times, right? So do you know the shortcut for if you want to add something multiple times? Multiply? Yeah, we're going to multiply. So a shortcut is to multiply the amount times the frequency. So 1 times 5 is 5. 5 times 8 is 40. 10 times 2 is 20. And 20 times 1 is 20. Then you can add those together, 40, 60, and 85. And so that's how you can get your total. Here's 85, which actually it's still on my calculator. That's the total we got before. So a shortcut when you have a frequency distribution is to multiply the category by the frequency, and then add all of those up. That's what this notation at the top means. This means multiply the data by the frequency and then add all of those numbers together. So XF, data value times frequency, add all of that up. Then to find our mean, we've got to divide by however many things there are. So in this case, they told us there were 16 children. So we can do 85 divided by 16. And we get 5.3125. So to the nearest cent is the nearest hundredth. So we've got this 1 here. To the right of it is a 2, so it's going to stay a 1. So this will be $5.31. There we go. Now, if they didn't tell us the 16, do you remember how you find a sample size from a frequency distribution? So the way that you do that is you go to the frequency column and you add up however many those sum to. So 5 and 8 is 13, 14, 15, 16. So if I show my work this way, this is good. It'll get me the full credit for my class. I am going to show you another way that you can show your work, just in case you want to show your work differently. So an alternate way to write this would be I did 1 times 5, and then 5 times 8, and then 10 times 2, and then 20 times 1. So this is what we did to get these numbers here, and then we added them all up. And then to figure out what to divide by, we added the frequencies. So we did 5 plus 8 plus 2 plus 1. And then in the top, we would get 85, and in the bottom, 16. And that would give us our 531. So some people like to show their work kind of in this linear fashion where it's all in one spot. But if you also want to use the table instead, you can do that and show your work kind of in a different way. So I'm okay with either ways of showing your work for our class. Okay, so that's going to wrap it up for this video about the mean. In the next video, we're going to talk about another type of measure of center, which is called the median. So I'm looking forward to seeing you then. And in the meantime, have an excellent day.